Okay guys, let's take a look at our lesson for today. We're going to look at tangent lines and derivatives. Let's do some reminders. We've had a lot of this already before. For average rate of change, we studied this a couple of units ago. Average rate of change is the slope of the secant line, and this is the formula for it. Basically, it's a fancy slope formula. So we'll be encountering this concept in this lesson. Instantaneous rate of change is our derivative. There are many uses for the derivative. I've listed a few down here. We'll talk about them in just a second, but let's talk about these two concepts, instantaneous rate of change and the definition of the derivative at a point. These are two formulas. This is the definition of the derivative, and this is the alternative form of the definition of the derivative. Either one of them will find you what you want. You are welcome to use either one. My preference is this one. That's the one that I will be working with, but if you want to use this one, you certainly are welcome to. Gail will give you the same answer. So both of those are good formulas. We're more accustomed to the definition of the derivative instead of the alternative form. We've been using it all year, so I'm just going to stick with that one. I will use the definition of the derivative at a point. You don't have to memorize these at this point. For next year, you certainly will need to know them, but in PreCal, we will give you this formula on a quiz or a test. So let's look at just some concepts that we need to cover. F prime of A is a value of a derivative at A, whatever A happens to be, whatever X value that is, and it stands for many things. We've used it for basically the slope of the tangent line. We've used it for that. We also have talked about its use as an instantaneous rate of change or instantaneous velocity. So there are many uses for the derivative. We're just kind of scratching the surface. And so that's the setup for the few problems that we're going to be working on. Are there any questions? All right, it's important, and I've bolded this so that we all are on the same page here. In order to work all the problems on the notes in the homework, we are going to have to find the derivative first or use one of the above formulas. Now, as far as finding the derivative with the power rule, I am fine if you use the power rule. Okay, that's fine. And in fact, I'm going to use the power rule on number 1. But that only works for us on polynomial or polynomial-like equations. For this one, requires additional rules in calculus. It's called the chain rule, and we're not going to do that. If you see something like this that is not a regular polynomial looking thing, you're going to need to use the definition of the derivative. We've got to be comfortable with and accustomed to using the definition of the derivative. Alright, so you'll have two types that you're working on. You're going to be able to use the power rule for something like this. And for something like this, you're going to have to use the definition of the derivative. Okay, questions? Alright, let's practice that. Okay. And that applies to your homework as well. You really need to practice how you're going to be quizzed and tests. I think perhaps, end of the year, we're a little tired. Maybe we're taking shortcuts. The shortcuts that you take in your homework are going to show up on your quizzes and tests, and you will not do as well as you would have if you had fully worked these out as you were supposed to do. I'm just letting you know. So we want to find the equation of the tangent line to the curve at the given point. So what we're looking for is, we're going to use my favorite equation of a line. Y minus y1 equals m times x minus x1. And when we get it in that form, we leave it alone. We don't try to distribute, combine like terms, all that stuff. We just leave it alone. Just leave it in that nice form. So we actually already have been given x1 and y1 in both problems. So that's kind of nice. If you weren't, and there will be many times when you're given the x and not the y, and I just want to remind you if you're giving the x value and not the y value, how do you get it? Some students just freeze and don't know what to do. I don't want that to happen to you. So if you're only given the x value and you're asked to write the equation of a tangent line, how are you going to get the y value? Yeah, you're going to substitute it back in, right? So it's something you've been doing for years. I don't want that to trip you up. You just substitute it back in and get the y value back into the original equation, not the derivative. Okay, you take the 1, put it in here, and that would give you your y value. Okay, so all we are lacking on these problems is actually the value of the derivative at 1. So with this first one, we'll do y prime. We're just going to use the power rule because it's a polynomial. So just recall the power rule. Remember, we bring the exponent down, so 3x. Then we subtract 1 from the exponent and get a 2. And then the derivative of negative 2x would just be negative 2. The derivative of 3 is 0. So we used our power rule to get our derivative. Now to get the value of the derivative at 1, and I want it at 1, not at 2, right? We got to keep that clear. This is the x and this is the y. I'm going to be substituting the x in here. I want to know y prime of 1. That's going to give me my m. So my slope is the same thing in this case as y prime of 1. So I put a 1 in. I get 3 times 1 squared minus 2. That's a 1. So now I'm ready to write my equation. I just do y minus y1, which is 2, equals m, which is 1, and it's a 1. You don't have to write the 1. I'm just showing you the format. M times x minus x1, which is 1. And that's our equation of our tangent line. No sense in moving it around and shaking it up. It is fine the way it is. Questions? Okay, so, and we've been finding an equation of tangent lines for months now. I'm hoping that you're quite comfortable with it, because you'll continue doing that next year in calculus. Now on number 2, we cannot use the power rule here. It requires additional derivative rules, which we're not going to get into this year. So we need to use the definition of the derivative. We need to practice that. So we do the definition of the derivative. Limit as h goes to 0. Now I'm just going to remind you, if you look up to the top, I'll just scroll up a little bit. Look at that formula right there. See, limit as h goes to 0, f of a plus h minus f of a over h. Okay, so that's what I'm subbing into. I'm subbing into this formula right here. Let's scoot it back down. Okay. So, remember the first part was f of a plus h. Now, a is 1 in this case. Okay, we're using actually a form of the definition of the derivative. It's kind of a single-use form. We just want one number out of it. We don't need to find the equation like we did here. Here we found the actual equation of the derivative and we substitute in. So this equation will yield any derivative I want. You know, any value of the derivative I want. What we're going to be doing over here is we're going to be using a single use. We're just going to get a number out of this, and it actually makes this definition of the derivative equation easier to work with when we're not working with, you know, an equation, when we're just going for a number. So in the numerator it's f of a plus h. So my equation is x plus 3, and so we want a plus h to replace the x, right? That's how that works. I guess it would probably be easier if I wrote the equation up there for you. Let me just write it up here so we can reference it. Okay, so recall function notation tells us that this stuff inside the parentheses stands for x. And so what I'm doing is I have an x right there. I'm going to take that x out and I'm going to replace it with a plus h. Well, what's a? A is 1, because my formula I'm doing specifically for this equation. So a is 1. So I'm going to take the x out, and instead of a, I'm going to put 1 instead of a plus h, I'm going to put 1 plus h in its place. 1 plus h. And then I have my plus 3. So I'm just substituting in according to the formula. Minus f of a. Well, that means I take the function, and instead of putting, you know, an x there, I'm going to put a, which happens to be 1 in this case. So I'm going to do the square root of 1 plus 3 over h. Now probably the substitution part is the hardest part. Once we get that, then we just do normal limit solving techniques. Are we okay with the substitution? The a will change depending on the problem that you're working. A is just standing for the x value where you want your derivative value. Okay? Are we okay with that? Okay, so A is going to change depending on the problem that you're working. So now we just have a limit to solve. And I have 1 plus h. Let's just clean it up a bit. It's just a bit messy. So limit h goes to 0. So I have, what, the square root of h plus 4 minus square root of 4. And the square root of 4 is 2 over h. Okay, when we look at that, if I plug in a 0, I'm going to get 0 over 0, aren't I? If I get 0 over 0, that means that we have an answer. We just need to work for it. We need to do some algebra. So what algebraic technique might we try with something that looks like that? Yeah, multiply by the conjugate, and that's what we would do. So let's multiply by the conjugate, square root of h plus 4 plus 2 over square root of h plus 4 plus 2. So we get limit h goes to 0. So first times first gives us h plus 4. Outside, inside goes away. That's the beauty of the conjugate. And the last times the last, negative 2 times a positive 2 is a negative 4, all over. Remember, resist. Resist the temptation to distribute in the h. Do not do that. Wait until the end, h plus 4 plus 2, or you may miss the magic that's going to happen. All right, so the 4 minus 4, it's gone, right? It's 0. And I have these h's. We would have experienced this on the homework last night, right? The h's would have gone to 1. So this is going to yield limit h goes to 0 of 1 over square root of h plus 4 plus 2. Now I did a couple steps at once. Hopefully that's not troubling. I did 4 minus 4 and got rid of that, and then I canceled the h's out. We okay with that? All right. So at this point, I can substitute the 0 back in. I should be good to go. So put the 0 in. I get square root of 4, which is 2. And I get 1 over 2 plus 2, which is 1/4. Check my arithmetic. Are we good? So now that's my m. So let's write our equation of our tangent line. So y minus y1 equals m times x minus x1. And we're done. I encourage you to not distribute and combine like terms. Now, we all know how to do that, right? It's not because you don't know how to do that. It's just, it's best to leave it in that form in preparation for the free response on the AP test. Just leave it like that. Okay? How are we with the first part? All right, let's do our last problem. And I learned my lesson. I'm keeping the writing in case the writing doesn't show up. Maybe there's a way to put it back. I don't know. Let's hope. Our last problem tells us that we have an object dropped from a height of 3,000 feet. Its distance above the ground in feet after t seconds is given by, and it gives us an equation, h of t equals 3,000 minus 16t squared. Find the object's instantaneous velocity after 4 seconds. Well, the first thing we've got to figure out is what in the world are they asking us for? We need to know what they're asking us. Instantaneous velocity. We just talked about that just a few minutes ago. That is one way to represent instantaneous velocity is by the derivative. And if I want the instantaneous velocity at 4, what do you think it's asking me to do? Find the derivative, sub a 4 in it, right? That's what it's asking me to do in math talk. So that's what we want to do. Since this is a polynomial, you are welcome to use the power rule. Okay, if it wasn't a polynomial, you would need to use the definition of the derivative. But it is a polynomial, so we're just going to use the power rule. So h prime of t equals, the derivative of 3,000 is 0. The derivative of negative 16t squared, see, I bring the 2 down, so what is that, negative 32t? Check my multiplication. You good? Now what we want is the instantaneous velocity after 4 seconds. So we want h prime of 4 is what we really want. H prime of 4, which is going to be negative 32 times 4, which is negative 128. Now, you don't ever want to leave a number bald. They call it bald. You want to put units on it if there are units. Does this have, did they give us units on this? Yes, we don't leave those off. So let's see, what are we in? We're in feet, and we're talking about velocity. How should those be done? Feet per second. Now, this is one way to leave it, negative 128 feet per second. What does that mean if velocity is negative? It's going down. So you can leave it like that, or you could say, this is one way, but we want to work on wording. Height is decreasing at a rate of 128 feet per second. Now notice how I did not write the negative there. This is the wording that I would want to see. What is happening? Height is decreasing at a rate of 128 feet per second. Why didn't I put a negative there? Because I said it was decreasing. If I say it's decreasing and I put a negative, that's a problem, isn't it? So you can write it like this with no explanation unless it asks, or this is actually the preferable one.